Okay, in our final lecture in this week on energy policy instruments, we'll talk briefly about trade-offs and co-benefits. When policy, in terms of the energy sector, has many different priorities. There's mitigating climate change, there's energy access and energy security falls into that category, energy poverty, and air pollution, and many other different priorities that a country might have: employment, indigenous renewables, biodiversity, things like that. And there's interrelationships between all these different priorities. Sometimes there are synergies between kind of the solutions for two of these, but sometimes there are trade-offs. First of all, a co-benefit is an action that has it's a positive side effect of taking action for a particular cause. For example, a co-benefit of reducing coal consumption to mitigate the impacts of climate change will also reduce the air pollution associated with coal. So air pollution is a co-benefit of mitigating climate change in this way. Another example here might be switching to wind energy from natural gas can increase employment because we're creating a wind industry in Ireland. So basically, two thumbs up, good for employment, good for greenhouse gases. An example here is energy efficiency, taken from this study of 6 countries, which undertook what's called a LEED certified building program. That's a leadership in energy and environment design. So when buildings are certified according to this particular design protocol, the United States, China, India, Brazil, Germany, and Turkey. And this study examined over a 6-year time period what the impact of these energy efficiency certificates in these countries brought, basically efficiency retrofits in these countries. About $7.5 billion, I think that was, not euros, in energy savings from reduced energy consumption. But when the study compared this against air pollutant models, it found 33 million tons of CO2 avoided, 51,000 tons of sulfur dioxide, 38,000 tons of nitrous oxide, and 10,000 tons of small particulate matter was avoided. We'll have some lectures on air pollution after that. And if you put a monetary value on those savings, and you can basically, there are estimates of what's called the social cost of these pollutants. It's strongly related to the carbon tax, by the way, in terms of CO2. But if you put a social cost to the economy, to society, that different economists would estimate, that puts the monetary value of these pollutant savings at between $2.3 billion and $9.1 billion. So, you're talking, depending on the uncertainty of the parameters that you use, and there are very high uncertainty, but basically maybe double the savings in terms of pollutant reductions compared with the energy savings. It also found that the US alone, the health benefits in the US alone, avoided between 200 and 400 premature deaths, 170 hospital admissions, 11,000 asthma events, 54,000 respiratory syndrome, 21,000 lost days of work, 16,000 lost days of school. So basically the climate benefits and the health benefits were very strongly interlinked. Energy efficiency in general is one of these things that has multiple savings in terms of lowering bills, lowering emissions, lowering health consequences of energy. And the implications of this is that policies really should attempt to consider these co-benefits when weighing different decisions, because you could get the same reduction in CO2 from maybe a renewable energy program or EVs or something like that, but you might not get the same health benefits. On the other side of the coin, then, there's a trade-off. That is what happens. That's a trade-off is a situation where a decision to solve one problem diminishes the outcome of another response. So, for example, a trade-off of improving energy access could be increasing CO2 emissions if the energy access was provided with, say, gas or coal. Another example of a trade-off could be when you impose a carbon tax, then you increase prices. That reduces energy security at the household level. It decreases it increases energy poverty. And another example of a trade-off here is a study I was involved in back in 2013, which looked at the impact of a change in the tax base of vehicles in Ireland. So in 2008, in an attempt to incentivize people to buy lower emitting vehicles, which is good, the tax for vehicles switched from being based on engine size to being based on CO2. So now, as if you have a car, you'll know that you're falling into a certain CO2 band, and you pay your annual motor tax based on what CO2 band you're in. Also, the registration tax, the vehicle registration tax, when you first buy a new car, is linked to its CO2. Before 2008, that was based on engine size. You can see here that, first of all, it succeeded in reducing the energy intensity and the emissions intensity of new cars by an estimated 7% in 2020, 12 years on. But what we really see is that was brought about by a shift from petrol to diesel. So if we look at the year before the tax change, 72% of cars were petrol, and that was only 42% in 2009. And basically that tax change accelerated the shift towards diesel cars in the fleet, because diesel actually for the same engine size is more efficient, and so the CO2 band incentivized these diesel cars over petrol cars for the same type of car. The problem with that is that diesel cars emit much more nitrous oxide emissions, which is a potent air pollution and causes asthma attacks and respiratory problems. And this analysis that I was involved in suggests that NOx emissions were 28% higher in 2020 than they would have been without the change in that purchasing pattern. So this was a strong trade-off. Let's go away. So that implies as well that policies need to be very careful about unintended consequences and not solely focus on one objective. There needs to be holistic assessment of different energy policy priorities.